Welcome to Trigonometric Functions of Triangles with Buzzy and Fredericka. So we're going to start by trying to, our goal is to teach you here how to find the sine, the cosine, and the tangent, this angle theta, given its coordinates x and y from a point. So you can kind of see what we have here. We're given x and y, and then from that we can solve for our r, which is just with the Pythagorean theorem, x squared plus y squared, the square root of that. So we'll draw a circle around that, but it's important to notice that this is not the unit circle. So if we want to be able to label our sine theta and cosine theta, we're going to need to scale this down to a unit circle. So we'll scale it down by a factor of r. And so we're just going to divide everything by r. So the radius becomes r over r, which is 1, and our height becomes y over r, and our width becomes x over r. And so now that we have this in the unit circle, you know from previous experience that if we're given a point on the unit circle, its distance from the y-axis is cosine, and its distance from the x-axis is sine. So we just label these really easy like that. So x over r is our cosine, y over r is our sine. From previous experience, you know this to be true. And tangent is by definition just sine over cosine, which is going to become y over r over x over r, which is just y over x. So an easy way to remember this is with SOHCAHTOA. So sine is going to be your opposite over hypotenuse, so. Cosine is going to be your adjacent over the hypotenuse, ka. Tangent is going to be your opposite over adjacent because it's toa. So, and notice this is important because tangent can be any of the acute angles, either one. And your opposite is just the opposite leg from the tangent, and your adjacent is just the adjacent leg to the tangent. That's what we mean by opposite and adjacent. So let's give you guys an example. So if this is our theta, if this angle is our theta right here, and this is our right angle right here, what is the sine theta? So you can pause and think about that. So sine is just opposite over hypotenuse, which is going to be 3 over 5. So what about the cosine? Cosine's just adjacent over hypotenuse, which is 4 over 5. And tangent is just opposite over adjacent, which is 3 over 4. So it's important to remember your signs when you have this SOHCAHTOA going on, because it's not always going to be in the first quadrant. Sometimes we're going to be dealing with triangles in the fourth, the third, or the second quadrant, and we want to remember the signs. So remember, just when it's above the x-axis, that means it's a positive y value. Sine is just a y value, so sine's going to be positive. When it's to the right of the x-axis, cosine's just an to the right of the y-axis, cosine's just an x value. So it's going to be positive when x is positive. It's very self-explanatory. But if you need a little help to remember this, you can also use all students take calculus. So in the first quadrant up here, this is A, everything is positive. In the second quadrant, this is S. So only sine is positive because it's above the x-axis. It's a positive y value and a negative x value. I mean, you already know this from graphing, but if you want to remember it this way, you can. In the third quadrant, both our x's and our y's are negative. So when you divide those for tangent, it's going to be positive. And when you're in the fourth quadrant, then it's going to be a positive x value and a negative y value. So your cosine's positive, your sine's negative, and thus your tangent is also negative. So we're going to give you an example. So if we have this point, 12 comma negative 5, what is our cosine and what is our tangent of this angle theta here? All right, I'll pause. You can pause the video if you'd like and solve this out. So what we're going to start by doing is we're going to solve for our r, which is just using the Pythagorean theorem. So it's going to be 12 squared plus 5 squared, which is square root of 12 squared plus 5 squared, which is 13. And cosine is adjacent over hypotenuse, which is going to be 12 over 13. Tangents, your opposite over adjacent, which is going to be 5 over 13. Opposite over adjacent, which is 5 over 12. My bad. But it's important to notice that your tangent is going to be negative, because in this quadrant right here, in this fourth quadrant, our x values are positive, so our cosine's positive, but our y values are negative, which means our tangent's also going to be negative. So you just put a negative sign on it, or you can also use the fact that this is negative 5. You can't have a negative distance, but it is below the x-axis, so there's that.